So my name is Stanko Škec. I'm assistant professor from University of Zagreb, and I will try to help out with these sessions so that we can start. As you can see, we have 4 presentations today, which I think are really very interesting and which are related to different aspects of different types of industrial case studies. Professor Nespoli, I think I would suggest that you check your private settings in individual room, and then you can rejoin us here. So the first presentation will be given by Olle Vidner, who is PhD student and at the Design Automation Laboratory of Linköping University in Sweden. And so he will tell us more about design automation systems for the product development process, and of course introduce us into 5 industrial case studies. So I suggest that we start first with Olle.
Hello and welcome to this presentation for Design 2022 on design automation systems for the product development process, reflections from 5 industrial case studies. This work has been authored at the Design Automation Laboratory of Linköping University, Sweden, by me, Olle Vidner, Camilla Wehlin, and Anton Wiberg. Industrial product development processes are often iterative, with numerous interdependent and repetitive sub-processes. A common way of rationalizing this is by introducing design automation systems supported by design optimization to support parts of the process. An important aim for this work is to shed light onto the issues associated with the realization of DA systems. We believe that this can aid future development by supplying more information about the traits of previously carried out projects. The cases presented give an opportunity to draw conclusions on recurring challenges that needs to be handled in future development processes. As a result, the work summarizes issues which we believe should be considered in future research. To fulfill our aims, we here cover the application of DA and DO onto 5 industrial cases of different character, as well as the lessons learned from developing these solutions. The cases are all gathered from previous research projects and share the property of being conducted in partnership with industrial companies working within the engineering of mechanical products. Each case will now be briefly presented. First is the airplane bracket case, with the aim to enable configuration and optimization of component geometry for minimum weight and production cost by considering the structural integrity of the component, as well as its production process and associated cost simultaneously. The DA system for the airplane bracket is meant to support the product development process from the late conceptual stage all the way into the production stage. Next is the mobile miner case, with the aim to automatically propose viable design configurations and quotations from user requirements in the early conceptual and preliminary development stages. The models integrated in the DA system consider the product's performance, structural integrity, consumable consumption, and its overall return on investment. Third, we have the vehicle host routing system. Here, the aim is to generate conceptual solutions to host routing problems subject to a large set of physical constraints. This in turn should be an enabler for less iterations between departments, mostly in the conceptual design stage. The DA system works by modeling the design's geometrical feasibility, material cost, and structural properties. Moving forward to the 4th case of spiral staircases, the aim is to rapidly generate accurate quotations based on customer requirements, standards, and current stock status. By integrating models for geometrical feasibility, usability, the production process, and costing, the DA system can support the product development process throughout the conceptual, preliminary, and detailed stages, leading into the early production planning stage. Finally, the hydraulic pump case is focused on enabling additive manufacturing of hydraulic pumps through automated configuration, design, and analysis of structure, flow, production, and associated cost, all to support the process from preliminary to production development. Looking into the presented cases, a number of issues can be identified. To structure these findings, they are categorized along 2 dimensions. The first refers to the DA system's life cycle, spanning from development to deployment. The other refers to the domain of concern, spanning from organizational to technical issues. By considering these dimensions as orthogonal axes, we can get 4 fields into which we can map some common issues. Starting in the lower left corner, with the organizational aspect of development, the most notable issues relate to the difficulty of managing the development of a new solution to a new problem. In the studied cases, establishing clear goals has proved to be challenging, probably due to a lack of knowledge in the early phases of development. Likewise, settling on a clear definition of a minimum viable DA product seems to be a hard task. Both of these difficulties seem to indicate that the design paradox is fully at play when developing DA systems. Staying in development, but moving into the technical domain, uncertainties still play an important role. Often, tools and software that are new to the researcher are to be integrated. This, in combination with novel methods, can create issues with getting stable development environments in place. After overcoming this hurdle, a very important factor remains, that of handling model integration in a flexible way to enable rapid iterations in the development process of the DA system. Playing into this is the issue of computational complexity, contributing to longer lead times. Transferring the DA system to an industrial partner requires it to be packaged from its development environment into a usable independent system to be used on the partner's premises. This has been identified as an issue in all of the studied cases, especially due to unexpected incompatibility issues between subsystems. Ensuring that the DA system remains highly maintainable and flexible is therefore seen as crucial for a successful implementation, since both early and late changes to the system must be accommodated. Lastly, getting the DA system to actually support the product development process in the long term turns out to be hard. Especially so when the target process or receiver is not clearly defined due to key contacts changing roles or not having contact with the system's users. In general, the transfer of knowledge seems to be a key aspect of succeeding, as the long-term viability of the DA system is dependent on technical knowledge at the receiver's side. Concluding the findings presented in our paper, we can see that DA systems can offer ways to improve the design process and its results. Developing DA systems in collaboration with academia and industry does, however, pose some new challenges, as DA developers are influenced by double design paradoxes, one for the DA development and one for the target product. Therefore, we see that flexibility and maintainability are key technical factors, and thus propose that further research should be conducted on rapidly reconfigurable modeling and optimization frameworks. From the organizational perspective, scoping and knowledge transfer are identified as key factors in a successful DA implementation. Finally, we would like to thank you for your attention and interest in our work.
Thank you very much. So I would just like to ask whether Professor Nespoli can join us. Could you unmute your mic? No, okay. Okay, then I will just, then we can maybe proceed to the second presentation, which will be given by Thorsten Lutz, who is Director of Central R&D at Wehlin Group. And also he works as a mechanical engineer and actually as a head of production engineering for mechanical and software engineering at different companies. He also initiated a project concerning product service systems together with the Institute for Engineering Design at TU Braunschweig. So let's listen his presentation.
Good afternoon, ladies and gentlemen. I would like to welcome you to our presentation on our workshop series on transforming products into product service systems. My name is Thorsten Lutz, and I'm responsible for the Central R&D at the Wehlin Group, and I have worked together on this topic with Anja Cudok and Thomas Vietor from the Institute of Engineering Design from the University of Braunschweig. And in the following, I will present to you how we have developed a workshop concept for companies that want and need to transform their offer from products to PSS. And as an example, we have implemented it at our company, the Wehlin Group. Producing companies are underlying a volatile, uncertain, complex, and ambiguous environment, also known as VUCA. Challenges arise from ongoing changes in customer requirements, regulations, and influences such as digitalization and globalization, and to keep up with competitors, economic, social, and environmental criteria are of relevance when defining unique selling points for the company's offerings. In many cases, the transition of business models from selling products to offering product service systems, or in short PSS, is one opportunity to gain future viability, as examples from the supplier and automotive industry show. Examples can be found in various branches, such as mobility or the supply of consumer goods alongside a product. They form a huge variety of PSS, and that's why we wanted to take a quick look at the theoretical background of PSS. According to Tischer and Tucker, PSS consists of both technical products and services. They are integrated to provide customer value all over the system's lifecycle. Various models exist to describe and classify PSS, mostly agreeing on three categories differing in their shares of products and services: product-oriented, use-oriented, and result-oriented systems. And it stated that manufacturing companies change from offering products to PSS to increase revenues and profitability, but also achieve environmental benefits. Let's have a look at our company, the Wehlin Group, as it sets the example for implementing our PSS transformation workshop. The Wehlin Group is the world's market leader when it comes to processing machines for solid wood. The portfolio of the group includes processes like sawing, planning and profiling, pressing, scanning, and finger jointing, and offers standalone as well as large volume machines and industrial production lines. From small timber dimensions, for example, for furniture construction, up to large dimensions for heavy construction timber, a huge variety of parameters can be covered. We are now taking a closer look at the finger jointing technology that we have worked on within the workshop. Finger jointing is a wood processing method to produce the most stable longitudinal wood joints, and is one of the central processes in solid wood processing, both for the preparation of residual wood and wood upgrading. It enables the creation of continuous lengths to produce defined workpiece length in downstream processes, and furthermore, workpieces from which defects are cut out can subsequently be joined to form a defect-free workpiece. The whole idea for a workshop concerning PSS came up within another research project that had aimed at connecting SMEs and research institutes. The Institutes for Engineering Design had presented their current research, and the topic of transformation from manufacturing companies to service providers was the crucial topic for initiating the bilateral collaboration with the Wehlin Group, as it matched the company's needs and showed several approaches for a necessary transformation process towards PSS in order to secure its future viability. The workshop series included the following points: a shared motivation among the participants and involvement in the later change process should be achieved. An analysis and a common understanding of existing systems and challenges needed to be worked out as a basis for a systematic development of conceptual ideas, as well as the evaluation of the results and drafting of further steps for realization. In the conception of the workshop, we decided on 5 sections that are distinct from each other. First of all, the goal selection to reach a shared understanding of the situation and aims, and to motivate the participants for the workshop and the transformation process. Secondly, a system analysis to build a shared foundation of knowledge and impressions of the system under design. Then we went on into the conceptual design phase to develop first basic concepts that were then detailed into solutions that could be evaluated within the last step. The desired concepts are expected to concern several subsystems and just departments from the company, such as product and software engineering, service, and innovation management. The participants were chosen accordingly. They enabled a good overview of the product and its life cycle, and to include further internal stakeholders. I would like to mention some examples, such as system context diagram, life cycle visualization, and pain and gain analysis in the analysis phase, and personas and prototyping within detailing the concepts. Within 3 workshop days, we were able to work in a positive and focused atmosphere and derive a shared understanding and aim for all participants. We just want to give you an overview of our results. For example, we were able to derive inputs and outputs, as well as disturbing factors for the finger jointing production line. These factors were later in the process used and starting points for concepts. Here we have listed results from the conceptual phase to show you the variety of concepts that have been developed within our workshops. We were able to organize them in the 4 categories: product improvement, production optimization, services, and training. We mentioned just a few. For the product itself, it is intended to integrate sensors for data acquisition and interpretation in order to generate added value for both the customer and Weinig. Customer-oriented services like a configuration tool and the proposition of updates and upgrade for existing production line would build better customer relations and give Weinig more control over the system's lifecycle. To sum it all up, let's have a look at both the workshop concept and the impact for the company after its implementation. We can say that we have developed a successful workshop concept that revealed high potential for product service systems within the broad categories of product, production, service, trainings, and related business models. The workshop concept is generic and easy to transfer to other companies or branches. In addition, methods can be adapted to other teams, departments, or sizes, and methods could be exchanged or expanded. Taking a look at Weinig, the concepts found are a very good starting point for the transformation towards PSS. Further actions now need to be the organizational orientation and severe commitment towards the transformation. The effort for planning of the implementation might be high, but for several concepts, the effort for realization is seen as low and manageable. The next step will be to define resources, the structure, division of labor, and to develop necessary competencies suitable for the favored concepts. I would like to thank you all very much for your attention, and I'm looking forward to the discussion.
Great, thank you. So now we will have another presentation from Paulius Stulga. I apologize immediately if I butchered your name, so I'm really sorry for that.
That was quite fine.
Okay, great. So Paulius, he holds a bachelor and master degree in manufacturing engineering. He also previously worked in industry as a manufacturing consultant, and later he, of course, works as a research assistant at the University of Strathclyde. So let's listen his contribution to this conference.
Hello, everyone. My name is Paulius Stulga from the University of Strathclyde, and I will be presenting my paper on sustainable manufacturing with Industry 4.0. Specifically, we will take a closer look at the textile industry and see how sustainability and Industry 4.0 have impacted textile manufacturing. And finally, we will present an implementation framework which was designed for the textile industry. To give a brief introduction to this research, a few concepts can be kept in mind. First one being sustainable manufacturing. And in most cases, we see sustainability being considered from the so-called triple bottom line perspective, which means that we want to protect our environment, do so in an economically sustainable manner without compromising the well-being of the people involved. The second concept is Industry 4.0, which is a term that we use to describe the modern era of manufacturing. And very often, Industry 4.0 is presented through its core technological pillars, some of which are artificial intelligence, cloud computing, augmented reality, and robotics. What is interesting about these two research areas is that we could see a new emerging research area in the past few years where Industry 4.0 took a more active role towards enabling sustainable manufacturing. So we took this knowledge and decided to take a deeper look into the textile industry, which is being observed through a sort of a sustainability lens by the consumers as well as the government. Some of the main areas of concern are found to be value chain transparency and product traceability, energy and pollution control, capability for implementing circular economy, and manufacturing efficiency. Most importantly, we wanted to see to what extent the textile industry have been using Industry 4.0 to enable sustainable manufacturing. So we started by collecting data to see what the state of art within this industry was. We found that most of the academic contributions are on a conceptual level, The industry surveys show that most of the respondents from the textile manufacturing sector lack the general knowledge and readiness for Industry 4.0 adoption. There are some cases that show effective uses of Industry 4.0, especially with the technologies such as the Internet of Things and cloud computing, which are shown to have a bigger impact for supply chain management and product traceability. It is also worth mentioning that the commercial market for Industry 4.0 related technologies for the textile industry is quite active in terms of new and innovative products. So the gap that we found is that in its current state, the textile industry has a low adoption rate of Industry 4.0. Some awareness exists towards the benefits and implementation guidance, but it is not actively used. So the general outlook is that the manufacturers are at an exploration stage. The textile industry lags behind other industries in terms of Industry 4.0 adoption, which can have a negative impact towards adopting sustainable manufacturing as well. Finally, the data from industry surveys proves that there is a need for a more specific guideline. So as a result, one of the research outputs that we created was an implementation framework. What is special about this framework is that it is designed for a particular industry. So this framework consists of 4 core steps. First one, defining specific requirements for implementation, creating a value map, ranking of Industry 4.0 technologies and applications, and finally selecting commercially available technologies and services. So let's take a quick look at the framework step by step. The requirements for Industry 4.0 implementation have 3 main elements. First of all, manufacturing characteristics can have a large influence on the applicability of Industry 4.0 technologies. Examples of such characteristics can be a company's level of automation, product's complexity, mix, and volume. The second element is the definition of sustainability objectives. And these will create a list of key performance indicators that must be improved. And lastly, the Industry 4.0 value mapping, which is extended into the second step of this framework, where we map out the Industry 4.0 technologies found to be used in textiles manufacturing, as well as mapping out Industry 4.0 applications found to be used in textiles manufacturing. So the purpose of this is to accomplish step 3, which is to create a ranking of relevance of certain technologies and applications. And finally, step 4 requires a selection of available technologies and services that will best fit the requirements defined in step 1. In simple words, the framework intends to channel different groups of companies that have similar characteristics and objectives towards certain Industry 4.0 technologies and applications. And that was my last slide.
Thank you for listening.
Okay, great. Thank you. So, by the way, I managed to turn on the camera so you can see my, I'm not sure whether you benefit from my video, but at least we can see each other in a way. So also, once again, I would like to remind everyone that if you have any questions, all the participants, please just drop it in chat, and we can then reflect on that later, on these questions later. So the following presentation will be given by Jonathan Edward Page. He's commander at the U.S. Navy, but also he's PhD candidate at MIT. With also previously he obtained a master's as well at MIT, and also worked as associate professor, and with very I would say broad industrial but also academic experience. So we are all looking forward to the following presentation.
Good day. It's a pleasure to be able to provide a snippet of the work we've conducted with the U.S. Navy to extend the use of set-based design to a large-scale project. This work is my own and does not necessarily reflect the views of the United States Navy. I performed this research with Mr. Chris Higgins, the Senior Ship Design Manager, and Professor Warren Seering, my advisor and chairman. To quickly set the scene, the U.S. Navy has an incredible challenge. We have peer adversaries looking to disrupt the rules-based international order. They get a vote on our needed capabilities as a result. The speed of change for technology, requirements, mission needs, tactics, and threats is increasingly difficult. At the same time, ships can take 15 to 20 years for new development and have long service lives after delivery. Maintaining relevance in light of these challenges is incredibly important for these large capital investments. Lastly, designing these floating cities only increases in complexity with time. Therefore, when we set out to design a new large surface combatant, now known as DDGX, we took lessons from Toyota's performance in their global competition and applied what we could for a naval vessel design. We decided to use a set-based design method to evolve our knowledge and address the complexity of the design. We decided another key effort was to incorporate flexibility to address uncertainty and value sustainment and give future leaders affordable and efficient options. Part of our predicament, though, was not having many examples to use in establishing these methods, especially at this scale. Therefore, we had to use the method as we designed and modified it. This invoked participatory action research, where the researcher is actively involved in change mechanisms for a group of people. It framed the efforts for us to prepare, act, and reflect on the people and processes conducting set-based design in situ. Our instance of set-based design has four main parts. The first is the philosophy we put behind it. Our basic design philosophy was to rapidly develop an affordable and flexible ship class that will potentially serve the Navy into the next century. We shared how to execute this philosophy through design guidance memoranda. One can see the philosophy coming through just in the titles, each of them managing risks and communicating policy in their own way. For the team organization, we chose a hub and spoke model for a few reasons. First, it matched reasonably well with our existing parent organization, Naval Sea Systems Command. Second, it helped us manage the teams and cross-domain communications. At first, all communications came through us at the hub. We did not allow cross-domain communications. The team was small, and this was manageable. But after about a year, the sets were developed, the team had grown, and we were mentoring on some of the same issues with each domain. So we expanded and conducted set reviews with every domain present instead of just one. This enabled the entire team to train and mentor and learn collectively. Third, it allowed the team to scale and grow appropriately. We expanded the hub, the spokes, and the whole team together, and we can see that the underlying structure remained as the team expanded. For the process, set reviews were the structured meeting for decisions, intersections, and communications. They reviewed the information in an established format with the senior ship design manager to get a decision. Each set review was like an experiment in our test rig of the process. There was typically one per week at first, which grew to 3 or more per week, especially after we switched from ad hoc to a structure where each Thursday was dedicated to set reviews. Also, set reviews were where integration by intersection occurred in our process. It was a very human-centric effort. There was no custom tool set to aid negotiations and communications. Instead, it was basically humans talking to each other and reasoning and negotiating with each other to inform decisions. Finally, those decisions in the process were documented extensively. We called the document a design decision memorandum. It contained a standard form to capture key elements, the presentation given to the SSDM, and the minutes from the meeting, which often included chat room conversation, word for word, when available, since much of this took place during the global pandemic. Decision memos represent reusable design knowledge in many cases because we capture the assumptions, analysis, outcomes, decisions, and other pertinent information all in one document. It also captures the context of the decisions through the conversations, including who agreed, who disagreed, what the impacts to other functional areas were, and who was present, among others. The net result was a process that scaled in complexity and quantity, and importantly, did not crumble under its weight. Here we see data from the first year at the top, second year at the bottom, and a summary chart in the lower left. Every dot is a review. Solid dots produced a design decision memorandum. The solid line separates original sets from new sets, and the dashed line separates the ad hoc structure from the structured reviews on Thursdays. One can visually see that the acceleration of the process. There were more sets, more reviews, proportionally more DDMs, in addition to more people and more results and more integration as time went on. Notably, it continued to grow in the third year and produced more results, even while the budget shrank, demonstrating an additional layer of efficiency for the team and process. In conclusion, we established a process and team structure that scaled set-based design up to a system of systems. We look forward to set-based design's continued expansion and use, including transferring the practice to other ship classes and other decision processes. We have many lessons learned we are happy to share. Of note, this is not the ship, but represents what it could be. We thank you for your time and look forward to any discussion this generates.
Thank you very much. Great. Very, very interesting talk. And now we have the final presentation, last but not the least, Eliab Opio, who is professor at St. Joseph University in Tanzania. And this research was conducted in collaboration with the Blacking Institute of Technology and with Diana Shagar University in India. So let's listen to this presentation.
Hello, welcome to presentation of paper number 139 entitled Conceptual Design in Metalworking Microenterprises. This is the outline of this presentation. We will present the background, the aims of the research question, methodology, and also the findings of the research. Now, about the background, well, enterprises in developed countries differ significantly from those in developing countries. However, most design research focuses on developed countries' enterprises, and there is limited research in developing countries. So the aim of this research was to explore metalworking microenterprises in developing countries design products. So these are the research questions that we attempted to answer in this research. How informal metalworking microenterprises identify customer needs and requirements, and how do they generate and evaluate alternative concepts. And the methodology we followed can be described as follows. Semi-structured interviews were carried out in 10 informal micro-enterprises in Dar es Salaam and coast regions of Tanzania. And the interviewed informal enterprises produce a wide range of products such as furniture, window grills, doors, charcoal stove, and so forth. Now, these are the findings of the research. Now, on elicitation of needs, it was found that interaction with customers is the main technique used to reach out to the customers to gather first-hand needs data. Pictures are used as stimuli for discussion during needs elicitation, and wishes and ideas about the intended product are articulated verbally or by using sketch. Now, on the scenario of interview with customers, it has been observed that rough hand sketches and photos are referred to during conservations, and there is no culture of documenting and archiving conversations. Now, on sources of requirements, it has been determined that standards past experiences, technical constraint, expert knowledge, and brainstorming are the main source of requirement. Now, on organization of requirements, it has been found that most microenterprises prioritize requirement and priorities are determined in consultation with customers. It has also been found that requirements given priorities are those that describe functionality, material, and dimensions of. On concept generation, it has been found that this is optional for some firms. There are multiple iterations for one concept. Solution are provided by the client, and the client choose the solution mostly from the existing products. And on sources of idea stimulation, it has been found that YouTube, Facebook, and existing products are referred to during concept generations. Internet is accessed mostly by using smartphones. So desktop computers and laptop computers are not used frequently. On concept representation, it was found that majority of firms represent concepts by using sketches. And on concept selection, it has been determined that cost and functionality are the leading criteria for selection of concepts. And on material selection, it has been found that criteria used for selection are cost, functionality, and availability. And aluminum and steel are mostly used. Now, in determination of product dimensions, it has been found that this typically entails visiting the sites and is based on past experiences. Now, we have investigated how informal metalworking microenterprises in developing countries design products and undertook empirical study in Tanzania. And we have seen that how informal metalworking enterprises identifies customer needs and requirements and how they generate and evaluate alternative concepts. This concludes this presentation, and thank you for your attention.
Okay, great. Thank you very much. So thank you to all presenters. I think that we've seen some very, very nice, interesting new insights. Some of them also, I think it's really interesting how they try to transfer theoretical findings in actually findings from academia to industrial settings, which is often neglected and often, I mean, let's say, followed by several issues, which some of these papers, I think, clearly stated. So how I would start initially with questions from chat. Also, if you have some follow-up questions, or if you would like to add something or clarify something, please just let me know, or just send via chat also additional questions. So we have initial question. The first one for Olle, posed by James. Of course, he thanks you for presentation, and he agrees that the appropriate DEA for design problem is a gap. Of course, especially taking into consideration all the investments. So do you have any thoughts on how we reason about what DEA to develop? It feels expert-led at the moment. So if you could reflect on that.
Yes, thank you. I hope you can hear me clearly. So thank you for your comment and question. I agree that it is mostly top-down driven. If it is right up, we mean the academia or experts. Like you should want to have this perspective. I don't think there's a quick fix for this. But I mean, in the short term, we must make sure that we're not stuck in waterfall mode when developing these solutions. To make quick iterations with demonstrators. But I guess in the long term, we should secure the education of engineers familiar with DA and design optimization to give a sort of perspective from the bottom up instead, to drive the eyes that can see the potential for DA applications, and to drive from that direction as well. I don't know if that is an answer to your question.
I believe James will comment in chat, but I think I think you clearly shared your point of view, your viewpoint. So actually, what I want to ask you, I would like to follow up on this. So, what do you think? How the character of your projects that you analyze, of different case studies, to what extent this influenced your results? So, for example, complexity, design phases that are actually maybe. Were specific focus in your case study, I mean, type of, for example, geometrical complexity, and where do you see the highest cost benefit ratio for based on these initial, let's say, 5 industrial case studies?
Let's see, I'm going to take the one question at a time. So how these cases influence the results. I guess multiple of them has been, as said, driven from this direction that we have these industrial partners, but we also have we're the ones driving the requirements for the projects, and I guess that could be a reason of why we see the issues we see. But I don't have a really quick answer for that.
I believe this is maybe part of the follow-up study. Probably this is part of the follow-up study to better distinguish differences and characteristics of the different industrial case studies and try to map that to potentially some of the DEA suggestions or guidelines that you maybe plan to develop further.
Sorry again.
So I'm just suggesting that potentially this characterization and clear distinction between different industrial case studies could potentially help you to map guidelines depending on the type of the product, the type of the design phase, and depending on these, so that you maybe try to customize design automation guidelines as a potential step forward. So
yes.
Related to that, so Paulius asked question, are there any commercial services for DEA systems? Are there any tools and techniques that could actually help with selecting DEA systems, maybe for academics, but also for industrial practitioners?
Yeah, that is an interesting question. I guess there's some overlap with James' questions as well. I'm off the top of my head, I'm not familiar with any commercial services for that, but when it comes to tools and techniques, I think the lessons learned from our perspective is to engage more in some kind of action research to make demonstrators, quick and dirty demonstrators in shorter iterations, and try to use expose consumers or industry partners to these, and make sure that sparks some creativity among industrial users to see the capabilities of what we can do with DA today, and to also get this more practitioner perspective, not only the expert perspective.
Yeah, I mean, I definitely agree. I think that throughout this whole session, we could see different examples of how to transfer methods and what are the issues in terms of implementation. So related to that, also James posed question on some interesting findings and from the workshops that was conducted by Thorsten. And so how he's actually asked a question about introducing PSS. So how to bring findings together to decide whether to go or no go for PSS. If you could, Thorsten, reflect on that, please.
Yeah, I will instead of Thorsten because he has problems with his microphone.
No problem, Anja. Please feel free.
It works for me. So, okay. Yeah, we have since we have found quite a variety of solutions from the PSS workshop. It is really a bit difficult to decide on whether it's a go or no go for the specific single solutions, but. In the end, it comes down to business plans, I guess. So what we have done in the workshop is to provide the solutions, and then it goes into the Wehlin group, and they will work on business cases. And yeah, we have just started with small analysis on I don't know the English word, sorry. Whether it's feasible, maybe, and what duration it will take to implement a solution. Yeah, but then again, it comes down to innovation masters at Wehlin group who say or who decide which solution to take.
Related to that, what did you say? What were the main implementation issues of PSS concepts? I mean, very often when people try to implement some of these initiatives in industry, very often there is some kind of there are various obstacles, whether they're organizational, whether they're managerial. So what would you say? What would you commend? What's the main obstacle to that?
I guess Thorsten would say that the resources that don't exist just to put the necessary effort in creating the solutions or implementing the solutions. For me as an outstander, as I come from the university, I'd say maybe sometimes even mindset problems. So for example, when we gathered all the different departments in our workshop, it was easy to see who's open to PSS ideas and who's not. Yeah.
Okay, great. I believe Olle could jump in because actually he nicely explained us differences between managerial and organizational and also technical issues. So Olle, could you jump in and reflect on that?
I'm so sorry. I've been having some audio issues.
Okay, no problem. But also, I mean, related to that, so related to these implementation issues, I think that maybe I think both John and Paulius could join in and actually reflect on that. So what would you say, what are the main obstacles in terms of implementing different concepts? So Paulius, you're very high level. Industry 4.0 as such is a very broad concept, while John is more into set-based design. So could you comment on implementation and potential issues with implementing these into companies?
If I can go first, so taking a broader perspective, my research is done as a whole in a particular industry. So I've been in contact with a lot of companies, and sort of the conclusion is that there's probably two main issues in terms of implementation of new innovations. The first one being limited knowledge, and the second one, I think, which is maybe a bit more important, is that there is no actual stakeholders within the company that would deal with these innovations. I think it also depends a lot on the sizes of the company. So we always see the best practices coming from the large enterprises that have whole departments working on innovation, but seeing on the sort of SME level, I think there's really a need for some kind of intervention in these SMEs to sort of drive certain innovation.
Great. What about you, John?
Yeah, absolutely. Thank you. I think my response at sort of a team level for difficulty in implementing a new process, I'll I'll summarize my answer with habit. And what I mean by that is within the team, the engineers, the designers, they have been engineering and designing ships a certain way for, in some cases, 40, 50 years, right? That have given them a successful career. And out of habit, it's difficult for them to switch their mindset to designing a different way, making decisions a different way, because out of habit for some amount of time that has had them successful, they're hesitant to switch, right? There's a mental sort of hurdle rate to switching to a different methodology. And so there's risk in that, in that they'll continue to do what they've always done, and then call it set-based design, in my case, right? Like, oh yeah, I did set-based design, when really they were doing the same thing they've always done. And there are other risks inherent in that also, right? So at the team level, there's a habit aspect that they're hesitant to switch. And then at a stakeholder level, for the leadership that we report to, it's the same thing. They have the same habit that they've progressed and gotten into leadership positions by making certain decisions with certain information in a certain way. And in our case, in set-based design, our decisions, as I said on the last slide, this is not what the ship is, right? Like all of the decisions are, this is what we're going to rule out of the design space. So I'm going to make a decision on what it isn't. And the leadership, at least initially, hated that, to be blunt about it. But after about 6 months of iteration and presenting information in that way, they grew accustomed to it and grew to like it, right? So it took some strength on our part to just stay the course instead of reverting to things. But I don't want to take too much time. Again, the summary of my answer would be habit, right? Habit prevents folks from transitioning to new things. Over. Thank you.
I mean, very, very interesting. What I also noticed at the beginning, I don't know whether that's usual way how it has to be done from your side, but you immediately made a distinction at the beginning from U.S. Navy actually way of working. So if you could reflect on that, and what would be necessary so that you can scale up, for example, set-based design in U.S. Navy.
No, great question, and part of it is through what we just did, and what we continue to do on that particular ship. Part of the scaling aspect of it is getting leadership used to it, and getting engineers used to it and familiar with it and understanding how it works, and creating that reusable design knowledge, right? Because part of set-based design is I don't have to start from the beginning each time, right? I've designed a ship before. Why can't I use the knowledge I've already created in other ship designs to define the set of potential outcomes for this new process in front of us? So some of it is not just creating that knowledge as we did, but capturing it as we did, which gets a little bit into Paulius's question that he provided, that we're generating all of this data. Is there? So I'm going to scroll down to use his words. Opportunities for data analytics to gain more insight from the meetings and the design of ships. So the answer is absolutely, and that is what's absolutely needed. One of the critical pieces to scaling it to the larger Navy. Again, unfortunately for U.S. Navy ships, that's going to play out over a long time constant, right? Because we'll be designing this ship for the next 5 or 6 years before we cut steel. When's the next ship class going to come around where we can reuse some of this data? So it is going to take discipline on the part of leadership and the U.S. Navy to allow the practice to continue for ship design. But the real piece of it is capturing that reusable design knowledge for future generations to use to help them define their sets and use the data analytics that Paulius refers to. Absolutely. Great question.
I mean, what I'm thinking now when I listen all your comments and when we are thinking about transferring methods to industry, obviously there should be initially conducted some kind of maturity assessment regarding different types of organizational policies, whether that's, I mean, from I don't know, from risk management to general management and different practices that are conducted, so that we see what is the, first, that we can characterize companies, but also that we immediately have some kind of sense of what's the current status of certain company and how to proceed to define maybe certain stepping stones. So related to that, I wanted to ask Paulius, have you maybe checked, because I know that there are different types of maturity assessments for Industry 4.0, because what it's really interesting also is that when you mention small and medium enterprises, there's actually complete difference. I mean, so some companies, I mean, one size does not fit all. Maybe some companies, they do not need all these Industry 4.0 practices. So have you thought about introducing some kind of maturity assessments to actually set maybe some objectives and actually how to go forward with within your framework?
That's a tough question. I guess there are so many different maturity assessment models. I think, in my opinion, I've seen a lot of them, and they're all pointing in sort of showing the as-is state of the company. And if we, for example, look at SMEs, it's a bit more easy to assess those companies because they're smaller and they usually have one manufacturing department, one marketing department, one planning, and so on. For larger enterprises, each sort of department may have their own sub-departments and a lot of different manufacturing floors, which becomes quite difficult to assess that. So I don't think when we talk about an implementation framework for Industry 4.0, these assessment models may help in understanding the state that the company is, but we haven't really used that as a criteria for building our framework.
Okay, great. I mean, I agree that there is variety. I'm just thinking whether this concept could be interesting. Also, what I would like to ask you, actually all of you, unfortunately, I think that Aliev is no longer with us, but I hope he'll rejoin. But the question that I would like to ask to all of you, to what extent you could actually transfer these methods immediately? So for example, Paulius, you said that you used, you actually tailored the, let's say, some kind of Industry 4.0 framework for the textile industry. So my question is, to what extent you could use maybe some generic ones as a template, as an initial point? And actually, this is a question to all of you. So to what extent you could maybe take off the shelf set-based design method, or for example, PSS implementation, or for example, I don't know, design automation for dummies, how to implement that in companies. To what extent you could actually use off the shelf some of these design methods on how to introduce these things, and how would you comment this, let's say, customization? To what extent this was necessary? I would ask actually all of you, so if you could go in some kind of sequential order.
Yeah, may I start? I'd say, we have talked about it, whether our concept for PSS workshops is extendable to other branches, maybe, so sectors or industries. And explicitly, I try to choose methods or pick methods that are really undependent on the product itself, that is that we look at in the workshop. So we agreed on it is possible to use the same workshop for other companies who have technical products, at least. So maybe not the textile industry, I don't really know. I must say I will have to think about it, but a product where you have the input, output, disturbance factors from the outside, and technical processes, it would work for us. we wouldn't have to change that much, I guess. I hope, yeah.
I'll go next. Great question. Almost a ringer of a question for me, because I've already done that. So my job after being the deputy ship design manager, I'm on the staff for the chief of naval operations now, and we had to, Congress enacted a law that said we have to do land-based testing for a bunch of different ships for a bunch of different systems, which created some potentially conflicting requirements for all these ships who wanted to put their land-based testing sites for risk reduction. Of course, wanted to put it in the same place that was best suited for them, which required a more sort of enterprise approach to look across all of the potential solutions for all of the potential ship classes, right? So a little bit different kind of design space than for a ship, but a design space nonetheless, where we wanted to look at sets instead of point solutions. All these ship classes had created their own point solution that they're going to put their site here and execute a certain way. So instead I followed, luckily I had the philosophy already in place because I had just created it, but took a small team from this new set of stakeholders and walked them through what I knew to be sort of a set-based approach to making a decision on what is the best solution for the enterprise for all these land-based test sites for machinery, equipment, radars, you name it. And in about 4 months, we came through it, right? So I was able to apply this immediately in my next job. New set of stakeholders, people fresh to set-based design versus point-based design, new set of leadership, et cetera, et cetera. So yes, a bit of a ringer of a question for me. I've done exactly that and applied it in a new scenario. So thanks for making me look good, sir.
I'll try to have some input as well. I think taking these methods that we use and sort of applying it directly to the industry, I think one of the better ways of doing this is following certain standards that associations create. Like here in Europe, we have ISO. John in USA has ANSI, I think, and they create a bunch of these standards that not are necessarily technical, but more of a systematic thinking and sort of design based. Like Industry 4.0, for example, is very technical, but at the same time there are these reference architectures that are considered to be standards as well. Especially I think in Germany, there are quite a few that are technical, but at the same time, they are welcoming in putting your own input, but they give you sort of the landscape to work in to set your mind free in a way. But yeah, the short answer is standards are a very helpful tool to push this faster into the industry.
Yeah, and I think as we tried to outline in our paper, I think it's comes mostly from there's a fair gap in directly implementing DA systems in industry as we see it, but I think we can close that by finding ways to quickly package our solutions for them to be used in industry and to get feedback on that, and also by making more flexible implementations of design optimization and automation frameworks that can handle the quickly changing requirements that comes from actually making these demonstrators and getting feedback from industry, and so that we can adapt these solutions quickly and to new requirements. try to answer it in a short way.
Great, thanks. I mean, I think this is really interesting. I think it really raised some very interesting insights. Also, what I would like to ask, I think, which is also, I mean, I don't know how many. I mean, there's some audience that is listening. I think that there's something that potentially should be also teased out here is that actually the amount of knowledge that people have on certain concepts. So people very often take some of these things for granted, and they think that people from industry are willing to take some of the initiatives relatively fast, and also that they have certain level of knowledge regarding certain concepts, although maybe that's not the case. So I would like to ask if all of you could maybe reflect. So for example, Anja, you mentioned that Thorsten would say that mostly resources are the main reason, but also what was the actually preliminary state of, for example, knowledge regarding PSS? Are people aware of that? Paulius, so for example, within textile industry, are people familiar with, for example, VR, AR? To what extent? Why? Have they used it in some different domain, in different contexts? Olle, to what extent they're familiar with design? So, etc., etc. So I would like to ask if you could elaborate a bit more on actually the state of knowledge state that you encountered within these companies, and to what extent then you think that this could progress, and if you could reflect also on that pace of catching up.
Should I start then? My experience, although it's fairly limited, just being a second-year PhD student, it is that engineers in industry are generally not that familiar with design automation and what we can do with it, and that's why I think it's important to work with the education of engineers to give them a view of that, and it's to get better ideas of what we can do going forward with DA. But it's generally not that good familiarity with, from as I see it.
I guess I'd say from my point, it's the same for PSS. In our workshop, there were, I guess, Thorsten, please tell me otherwise, but I think we were 11 people from different parts of the company, and it differed a lot. So some of them were already aware of PSS and the concept of combining products and services, and some haven't even heard of it before the workshop. So it was a bit difficult to get them all on the same level. But for the workshop, we just had a session in the very beginning introducing PSS examples and using some company examples that have succeeded using PSS and developing really new concepts. I think, and it's also what Thorsten said to me, is that it's really difficult to get some of them to think in a more open way. Because they are in there, especially in engineering, I'd say, the construction part. It's really difficult to get them to think about things that don't exist yet, apart from the products. So instead of offering a product, they should offer a, what did we call it? All-inclusive package, yeah.
From the set-based design standpoint and the team and people's familiarity with set-based design, they had all heard the term, right? There have been publications, articles out there about set-based design, not just on Toyota, but also in the Navy. Something going for us is that we did have a policy in place for about 6 to 8 years now that said all future ship designs shall use set-based design. We just happened to be the next design effort coming down the pike that had to follow that requirement. So people were familiar with the term. They weren't familiar with the actual mechanics and implementation. So there was an incredible learning process there to go from point-based design and move them all the way past what I would call many points-based design, because many just interpreted set-based design to be many points and ranges of points, but to move them past, going from points to many points to actually get to full sets. So it's a developing knowledge base, getting people familiar with how to truly think about sets and to create the tools that allow us to analyze designs in sets instead of as many points or something like that. Yeah, the summary, there's really only familiarity with the term, much less familiarity with the mechanics of actually walking through a set-based design process. Over.
All right, I think I'm left as well. In regard to Industry 4.0, we actually have done some industry surveys asking what kind of knowledge they have on Industry 4.0. And back in 2018, 60%, I think, of the respondents said that they don't even know the term Industry 4.0. And the same survey handed out in 2019 brought exactly the same results. So we started thinking, is it possible that over the span of 2 years, the industry as a whole did not really, achieve anything, or did not really know what Industry 4.0 is? And then we realized that probably it's due to the terminology. And Industry 4.0 is such a huge concept that encompasses a lot of different kinds of technologies. So what we're planning to do in the near future actually is make a different kind of survey where we dig a little bit more deep into the specific areas of Industry 4.0 and actually try to avoid the technical heavy terminology and instead of asking questions, have you used or heard of big data, we're just simply going to ask, have you been collecting data in the past 5 years, just to give as an example. But yeah, overall, and it also comes with the extensive literature review that we've done, is that the industry usually does not really relate to the concept of Industry 4.0, but they can relate to specific areas of Industry 4.0.
Okay, great. I believe that potentially with this we can close the session. Although we have time for some final questions. Actually, James posed some interesting insights on digital engineering toolset and how actually both John and Eliab actually use that within their cases. So if you could maybe just reflect on digital engineering tools and to what extent that we use them.
Sure, I'll expand a little bit more on the answer. I was just trying to provide that as part of this effort, since we were standing it up from the ground, it was a very green effort. We were trying to stand up model-based system engineering and other digital tool sets like that at the same time. And the scenario that created is that some of those weren't ready on time, right? So it was a very, again, it was a very sort of human process, human interaction where it was someone showing up with a spreadsheet or with a PowerPoint presentation. It's both sort of scary and somewhat elegant that we can design a warship using Microsoft PowerPoint, right? But when you're presenting information for a decision, sometimes you need no more than that. And so for many high-level abstraction decisions, we didn't need much more than that because it was a pro-con type analysis. It didn't need to get down into the weeds of things. Those were saved for later. For instance, with the hull form, where of course we have computational fluid dynamics, but we weren't going to run CFD models on thousands of hull forms. We were going to make some broad strokes first before jumping into those very fine tool sets. So the interesting thing for digital engineering for us is we had nothing new and we didn't create anything new, but there is a bit of a call to
create the tool sets that can better accommodate thinking of designs in sets instead of as point analyses that I'm doing thousands of times over on the sets that I'm trying to create. So that's a little bit more than the answer I put in there. Thanks again for the question.
No, in general, I think that as we also, I think as academics often think that, I mean, sometimes we need to remember that less is more, so that sometimes we do not push too much information which cannot be grasped immediately, and that we are aware of these stepping stones because of the, let's say, lack of knowledge on certain aspects, so that we can actually proceed and guide our practitioners towards, for example, our let's say aim or objective of our study, or actually final implementation of certain concept or method. With that, I would like to wrap the session. I mean, I took into account that there was a small delay at the beginning, so actually this maybe this session lasted longer than maybe others. Unfortunately, Professor Nespoli couldn't join us, but I tried to fill his shoes. I don't know to what extent I succeed, but of course it would be way better if there would be Professor Nespoli. But once again, I would like to thank all the presenters. I would like to thank the audience for questions. Thank you once again for a brilliant session. We are looking forward to the session tomorrow, and I hope you enjoyed the sessions today. There is also a social program in Getter. I would also invite you to check, because I think it's quite intuitive and quite user-friendly and actually cool to check. And yeah, I'm looking forward to following discussions throughout the conference, and thank you once again.
Yeah, great job. Thank you.
Thank you.
Thanks, guys. Bye-bye.
See you.
See you.